These will be the last set of notes for you, so congratulations, you've made it to the end. We are going to be on, what's this section? I am not sure, 4.7. So make sure you put that title on there. It helps me find the keys. So 4.7, and our question for the day is going to be, how do I rationalize? And I'll talk about what that means. I'll put it in quotes here. Rationalize the denominator. This actually is a really outdated skill. Unfortunately, it hasn't left the high school math curriculum yet. The reason it's outdated is because I'll tell you what happened historically. Historically, if somebody wanted to do 3 divided by the square root of 2, because the square root of 2 is not a perfect square, we call this an irrational number, kind of the root word of this. What that means is if you go to your calculator and you actually do it on your calculator, you're going to get a decimal that never ends and it never repeats. So you can never really write down its exact value, and you can't write it as a fraction. It goes on forever and it never repeats. So what would happen historically for something like this is they would have tables where you would go look up an approximation for the square root of 2. And then they would do 3 divided by that longhand. Well, what would happen then is, so I'm going to go do the square root of 2 on my calculator, and I get 1 point. The square root of 2 is about 1.412. So what would happen is they would have to take this historically and do 3 divided by 1.412-ish. And again, that's rounded. And they'd have to do long division with decimals, which makes you vomit in your mouth a little bit because that is like yuck. So they came up with a process so that they didn't have to do division by decimals. For example, if I told you to do 3 divided by 1.4, you'd go, ick, division, long division, decimals. But if I told you to do 3 times 1.4, I think most of you would know that you just do 2, carry the 1, and move the decimal over. Multiplication by decimals is not nearly as difficult as division. So historically, they came up with a way so that they weren't dividing by a square root. They were multiplying it, and that process is called rationalizing the denominator. So let's begin. How do you rationalize a denominator? I'm going to write this down. 1, let's even make it 5. 5 over the square root of 2. Now, I know you have a calculator and you could go get it and write down a decimal. That's why I said it's outdated, because we now have calculators that do square roots. But historically, not only did they not have calculators, they didn't have batteries. So it all goes back to the battery. Anyway, so in order to do this, what they would do is they would take the fact that they knew that the square root of 2, or square root of anything, times itself gives them, and you could write it one of 2 ways. You could say 2 times 2 is 4, and I know the square root of 2 is 4. Or root 2 times root 2 is root 2 squared. And these are what are called inverse operations. They wipe each other out. So anytime you do the square root of something times the square root of itself, you just get that number back. Root 8 is 8. Root a million is a million. Root 7 is 7. So what they did is, let's do the steps right here. They would multiply the top, the numerator, and the bottom, the denominator, by the I'm going to change colors here. Root on the bottom. So we multiply the top and the bottom by the root on the bottom. Let me show you what I mean by that. But I'm going to let you write that down. I want you to underline it. So what we did not like historically about doing 5 divided by the square root of 2 is we didn't want to do long division. So someone very clever said, you know what? I'm just going to multiply the top and the bottom by the root on the bottom. Now why can you do that and not change the value? Anything divided by itself is 1. So really, you're just multiplying that red fraction, 5 over root 2, by 1. And when you multiply something by 1, you do not change its value. Really, what I'm going to do is just kind of give it a facelift. It's kind of like fractions. It's perfectly legal for me to multiply the top and the bottom by 4, and then I get 4/8, and it's exactly the same value as what I started with. As long as you do the top and the bottom by the same thing, you're really just multiplying by 1 and your value will not change. So look what happens when I do that. On the top, I get the 5 times root 2. I can't multiply them because one's out and one's in. On the bottom, what I get is root 2 times root 2, which is 2. And you might say, no, it's root 4. Well, that's 2. Anytime you multiply a root times the same root, you just get that number back. This has the exact same value as this, but historically they liked this one better because they'd much rather divide by 2 than divide by the square root of 2. But now with the invention of calculators that do roots, honestly the first one's easier. So I'm teaching you a skill that I'm telling you is outdated, but you do have to know how to do it, and it's not very difficult. So we're just going to do a couple examples here. Let's do number 1. I'm going to do 4 over the square root of 3. I'm going to move down. Let's write down a 2. 6 over the square root of 2. And then let's do number 3. I think I might only need to do 3 of these. Let's do 15 over the square root of 3. Let's make it negative. All right, so what we don't like is that root on the bottom, so we do what's called rationalizing the denominator, aka make it pretty, make it nice. How do I do that? I multiply the top and the bottom by the root on the bottom. So I multiply the top and the bottom by the root on the bottom. That's really 1 in disguise. So I multiply straight across the top. 4 times the square root of 3 is 4 root 3. And I multiply straight across the bottom. Root 3 is 3. You might say, no, it's not, it's root 9. Yes, but that's 3. And then I ask you the question, does anything cancel? And if you tell me the 3's, it'll make me sad, because remember, we do not cancel when one's in and one's out. They have to both be in for cancellation. All right, so we will not cancel that. That would be our simplified answer. The blue one is exactly the same value as this red one. It's just considered rationalized or in better form, all right, because we don't have that root on the bottom. So let's go do the next one. Ugh, don't tell me that's 3, because one is out of the root and one is in the root. If it was like this, if they were both under, then that's 3. But this one, that is actually not a 2 on the bottom. You might be saying, I'm staring at a 2, LaRue, you're going a little cray-cray, but that is not a 2. It's the square root of 2, which is 1.4142. It's a big, ugly mess. So no dividing a 2 out of everything. What do? You multiply the top and the bottom by the root on the bottom. So top and bottom by root on bottom. And what do I get? On the top, one's in, one's out, so I can't combine them. I get 6 root 2. On the bottom, root 2 is 2. Now I ask myself, can I clean it up? And the question becomes, can I cancel anything? I can't cancel the 2's because one is out and one is in. So this and this will not cancel. Again, that really is not a 2 on the top. It's 1.414, blah, blah, icky. But I do have a 6 on the top. So I can divide a 2 out of this one, and I can divide a 2 out of this one. So my best answer is actually 3 times the square root of 2. Now let me understand, I want you to kind of understand why in math, and usually roots come about in building and construction and architecture, so they were working a lot with square roots when they were building things. It has to do with the Pythagorean theorem and all kinds of stuff with angles and lengths. But historically, they would much prefer to take the square root of 2, 1.41, blah, 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 and multiply it by 3. Then take 6 and do long division with a decimal. So they will give you the same thing. If you don't trust me, go to your calculator and do 6 divided by the square root of 2 equals, and then do 3 times the square root of 2 equals, and you will get the exact same decimal. All right, and this process again is called rationalizing the denominator. It's kind of like in English, you shouldn't say the word ain't. In math, you should not leave a root on the bottom. It's considered not done. So my last one, how does the negative affect it? It doesn't. Can I cancel? Nope. One's in, one's out. You're going to be dying to cancel a 3 out of the 15 because we were just working with all that fraction canceling in Unit 3. But that is not a 3 on the bottom. I know you're looking at a 3, but it's not. It's the square root of 3. And the square root of 3 doesn't even have a factor of 3 in it. It's 1.732050808. Goes on forever, never repeats. We want to get it off the bottom. How do we do that? We multiply the top and the bottom by the root on the bottom. Then we multiply straight across the top. Negative 15 times the square root of 3 is just negative 15 root 3. On the bottom, root 3 is 3. That's the whole reason you do it, is so that you can get root 9, which is 3, or root 3 squared, which is 3. However you want to think about it, I prefer this second one, that the root and the squares are inverse operations, like adding and subtracting, multiplying and dividing. They wipe each other out, and it gives you just that nice, pretty 3 down there on the bottom. Is it done? Obviously not. You might say, I'm going to go cancel those 3's. If you do, I might have to destroy you a little bit because one's in, one's out. Again, that is not a 3 on the top. It's 1.732050808. Goes on forever, never repeats, but I can divide a 3 out of the bottom. I can divide a 3 out of the top, and I end up with negative 5 times the square root of 3. So your next task is to go grab worksheet number 7. Worksheet number 7, it is gold. I would like you to make sure you can find your answers on the bottom. They are all listed down there, so you should be looking for those answers on the bottom of the page. Once you are done with worksheet number 7, you're done with chapter 4, and this is what you need to wrap it up. You will need to make your own study guide. You won't get to use it, but you have to make it in order for me to give you a practice test. So you're going to make a study guide, and that will be on the entire Unit 4. So it started with some proportions, and then it went to roots. It doesn't have to be elaborate. You just need to take each section and basically write down the summaries and make sure you know what you're doing on here. You need a study guide. You need a practice test. And then after that, you will take a test, and then you are done, unless you still have to take the final. So congratulations, yippee yippee doo-dah. We are done. Peace out, Girl Scout.